45, 45, 90 triangles and 30, 60, 90 triangles. So, let me make this a little smaller so we can see the whole thing. All right, so for that first slide here, we've got a circle drawn, and this is the unit circle because it has a radius of 1. So, what we're interested in finding for our 30-degree angle here are the coordinates, our x and our y coordinates of this end point on the circle. Okay? So, whenever we look at this, I could make a right triangle out of this. So I could draw this over here. I'm going to use a different color here and draw this vertical piece right here. And that would make a right angle right there. Now, this bottom side is going to end right here. And that's going to be the x-coordinates of that point. Because to find that coordinate, I would need to go over this much and then up this much, right? So I'm going to call that bottom side right there my x. And then this length of this red right here, that's going to be how high that point is. So that would be my y coordinates right there. Okay, so if we can find x and y, those are the coordinates that go with those points, which we need because we need on the unit circle, and then I'll show you what that allows us to do once we have that. So, I've got an angle for this triangle. Do I know any of the sides? There's one I can find out. The hypotenuse, what would it be, Valeria? It's 1, because the radius of the circle is 1. That hypotenuse right there, so from here over to here, that is a radius of this circle. So the length of this side right here is 1. So we could use trig and use our calculators to figure this out, but kind of a lot of the point of the unit circle is to not use the calculator, particularly whenever it was developed. So I also the other day showed you 30, 60, 90 triangle rules, which were, this is our 30-degree angle right here. If we know this side right here, I'm going to call it A, then the hypotenuse is twice A, and the longer leg would be A times the square root of 3. So, in this case, our short leg is our y. Right here, that A value is our y. We have the hypotenuse. How would we go from the hypotenuse back to our y? Divide by 2, right? Because to go from short leg to hypotenuse, we multiply, so we divide right here. So y is just going to be 1/2, right? So our y coordinate is 1/2. Then, what do we do to find our x coordinate? Multiply 1/2 by the square root of 3, which I could make square root of 3 over 1. So that is just square root of 3 over 2. So that is my x coordinate. It helps me here to think of the picture of this triangle when I'm trying to remember on my unit circle what values I have. If I picture drawing in that triangle, the x is longer than the y, right? Square root of 3 over 2 is bigger than the 1/2. So that helps me remember that square root of 3 over 2 goes here at 30 degrees. So let's transfer this to our unit circle. So right here, we're going to have square root of 3 over 2 and 1/2. Okay, everybody okay here? So you can see, like, these values that we're getting on the circle come from triangles, right? We could do, if we wanted to use trig, we could do values in between, but we're just doing the main values here. Okay? All right, let's look at the next point, at the 45-degree angle. Okay? So if I have a 45-degree angle here, I can do the same thing I did on the last problem. I could look at the bottom side and the vertical side. I'm going to call this bottom side X. I'm going to call that vertical side Y. The X is going to be my X coordinate right there. The Y is going to be my Y coordinate. And just like the last problem, I do still know one side. Which side do I know? Hypotenuse is 1 because this is a unit circle. All of the radii are going to be 1, and that is a radius there because it goes from the center to the outside edge. So my rules for 45, 45, 90 were that if I knew these two sides here, then I knew that this was a times the square root of 2. So for X and Y, they should be the same because they're both legs of this triangle, and this is going to be isosceles. So for X or Y, doesn't matter which one, how would I go from the hypotenuse back to the leg? We're going to divide by square root of 2. So X or Y, I'm going to put X equals Y equals 1 divided by square root of 2. But the powers that be of mathematics do not like it if you leave a square root in the denominator like that. So let's rationalize it. If I multiply by square root of 2 over square root of 2, I will get square root of 2 over 2. That's equivalent to 1 over square root of 2. It's just normally we don't leave it like that. So the X and the Y coordinates are the same here. I'll get square root of 2 over 2 and square root of 2 over 2. Okay, so let's add that to our unit circle. We got square root of 2 over 2, square root of 2 over 2. And that just leaves us this last one to do. It's going to be really similar to the first one, because if we know that angle right there is 60, then we're still dealing with a 30, 60, 90 triangle. It's just oriented differently. In fact, I know my sides are going to be the same as they were. I can see Y is bigger than X here. So Y is going to be the square root of 3 over 2. X will be the 1/2, but let's walk through it. So I know this side right here is 1. 30, 60, 90. If I know the small leg, then this is 2 times A, and then this would be A times square root of 3. So to get from the hypotenuse to the short leg, we would do X equals 1 divided by 2. So we get 1/2 for that X coordinate. And then for the Y, we have to take the short leg, which is 1/2, and multiply it by the square root of 3, which will give us square root of 3 over 2. Square root of 3 over 2 goes right there. And if you picture the points, you can see like your X is smaller than your Y. You're not going as far to the right as you are up. So you have those there. So if we add those to our big unit circle here, we've got 1/2 square root of 3 over 2. Now I could continue to go around the unit circle, and we could do this for all of the problems, but we don't need to. Because if you know the first quadrant, you can figure out the rest of the quadrants pretty easily. Because over here in the first quadrant, both my X coordinate and my Y coordinate are positive. In the second quadrant, I'm going to have negative, positive, right? X coordinates negative, Y coordinates positive. Down here in the third quadrant, I'm going to have negative, negative. And over here in the fourth quadrant, I get positive, negative. So we can just use symmetry to figure out the rest of these. So like if I take this point, square root of 3 over 2, 1/2, and I flip it over here, my x coordinate is going to become negative. So I have negative square root of 3 over 2. Y coordinate stays positive. I can take this point, flip it over here. I'll get negative square root of 2 over 2 and positive square root of 2 over 2. And then here I'll have negative 1/2 positive square root of 3 over 2. Okay, so do third quadrant. I'm taking this point. It already has a negative x coordinate. I need to flip it down here, which is also going to give it a negative y coordinate. So you'll have both of those being negative there. Right here we'll get negative root 2 over 2 and negative root 2 over 2. And here we'll get negative 1/2 negative root 3 over 2. And then finally, for our fourth quadrant, we're thinking about taking this point, flipping it down here, which will make your y coordinate negative, so you'll have a positive square root of 3 over 2, negative 1/2. Right here you'll have positive square root of 2 over 2, square root of 2 over 2. And right here you'll have, it should be a negative root 2 over 2. And then a 1/2 negative root 3 over 2. So if you can learn the first quadrant, you can fill in the rest of it just using that symmetry, right? So you need to have first quadrant memorized well. If you can't, like, just tell me right off the top of your head that 5 pi over 6 is negative root 3 over 2 and 1/2, that's okay. But if you can look at it and figure it, you can just look at it and figure it out. So the first quadrant, you need to have those pretty well memorized, so you could do it quickly without thinking about it. But then you can use that to find the other values on the unit circle. Okay, questions so far? All right, let's talk about why in the world this even matters. Like, what is this useful for? Why does this help, right? Because so far, it just seems like an exercise in looking at triangles and circles, but we're not getting anywhere with it. We're skipping this because we did it yesterday. I'm going to take it off of these notes. Oh, did I not put this? I need to go back and look at these notes. Okay. All right. So, this blank unit circle right here. I guess maybe that's what I was saying. All right. I want us to think about, we're just going to think about 30 degrees because it's easy to think about right here. So let's think about that triangle again. Okay, this is my x, this is my y. We said that my x was square root of 3 over 2, so that means this side is square root of 3 over 2. And we said that this side is 1/2, so it means that y right there is 1/2. Okay, and I know that this angle right here is 30 degrees. And I know this side right here is 1. So let's talk about what this does, why this is helpful. Okay, so unit circle can be used to find trig values. This was particularly important back before calculators, right? I know whenever I say that, you're like, you immediately want to shut me down because you're like, I have a calculator now, I'm not worried about it. But there was a time where this was extremely important because you couldn't do it without a calculator. Today, it's still important to understand the math behind it so that we can see how it applies to the next thing that we are doing here. So, we've got 30 degrees. So, it's helpful for trig values. If I think of sine of 30 degrees, right? Sine is opposite over hypotenuse, correct? So, opposite, in this case, would be 1/2. Hypotenuse would be 1. So, because this is a unit circle and your hypotenuse is always 1, this tells me that sine of 30 degrees equals 1/2. Right? So if we think about it more generally, if I do sine of theta, sine of my angle, is going to equal the opposite side over the hypotenuse side, right? So looking at that triangle, the opposite side might not always be 1/2, but it is always going to be your y coordinate, right? So, because your angle is always here, and even if you're over here in this on this side, looking at an angle here, opposite is always that y coordinate, is that vertical part, right? And then your hypotenuse is always 1. So sine of theta is going to equal your y coordinate over 1, which of course means that your sine of theta is just going to be your y coordinate. So at the top of your unit circle up here, it has an x equals and a y equals. Your y coordinate is sine of theta. Theta just being your angle there. So if I want to know sine of 120 degrees, I am just going to look at the unit circle. I'm going to find 120 degrees. Here it is. The y coordinate is my sine value. So that's square root of 3 over 2, right? Before calculators, that was really, really important because you didn't have a calculator where you could type in sine 30. So that was really critical. Now, I'm not going to make you guys learn it to the extent you would need to know it if we didn't have calculators. We do have calculators now. But that's sort of how this works. So if we think about this otherwise, sine, of course, is important. We also want to know about cosine. If I think about doing cosine of 30 degrees, that would be adjacent over hypotenuse. So that would be square root of 3 over 2 over 1, which means my cosine of 30 degrees would be square root of 3 over 2, which we can see is my x coordinate. If we do it more generally, like we did before, cosine of theta is always going to be the x coordinate over 1, which means cosine of theta equals your x coordinate. Okay, so up here at the top of your unit circle, we'll put cosine of theta for your x. So what we're going to be practicing today is using the unit circle to find trig values. Okay, and then tomorrow we'll extend that into looking at what happens whenever we change this from just looking at the circle to actually like graphing points. Okay, so before we can move on though, we need to think about, we're going to be asked about some of the other trig functions as well. So, the other trig functions are not directly on the unit circle. You cannot find them exactly on the unit circle. So like if I want to know tangent, I can't just look at 30 degrees and see what tangent is. But I can find it. Because tangent of theta is going to equal sine of theta over cosine of theta. Now I want to prove to you here for a second why that is the case. I'm not going to do it on all four of these, but I do want to prove it once. If I have a triangle, right, and this is opposite, and this is adjacent, right, I know tangent of theta is going to equal opposite over adjacent, right? That should be true. We have learned about tangent before. It's opposite over adjacent. So if I think about what I've got here, tangent of theta equals sine. What is sine? Opposite over hypotenuse, right? I could replace sine with opposite over hypotenuse. And then cosine, what is it? Adjacent over hypotenuse. That is a complex fraction. I do not like those. How do I deal with complex fractions? Dividing fractions, easy as pie. Flip the second and multiply. So that means tangent of theta would equal opposite over hypotenuse times hypotenuse over opposite. What's going to happen with our hypotenuse there? Oh, sorry. Yeah, I wrote that wrong. That's adjacent. All right, our hypotenuses, hypotenuse. Wonder which one's correct. I'm not sure. They cancel. And we have opposite over adjacent. So when we're doing sine over cosine, it is eventually giving us that opposite over adjacent. So this is just like a proof. In case you're thinking about majoring in math, which is great fun if you love math, but I didn't really realize this whenever I was in school. Whenever you go major in math, like you spend some of your time just learning like more advanced math, like higher and higher, like harder problems, longer problems. You know, you take calculus 1, then you take calculus 2, calculus 3. It's just like adding extra stuff to it that makes it more difficult. Then you eventually kind of top out on some of that stuff, and they have you take all these other classes, things like abstract algebra and my advanced calculus classes like this, modern college geometry. These classes actually were not doing, like, advanced calculus was not doing super hard, like, more difficult problem calculus. It was the proving of calculus. So it was taking things you already knew about calculus and then, like, proving that that's the case using logic. So it would be stuff like this. Like, you could very easily just accept what I say, tangent equals sine over cosine. But you're just like accepting the things that I'm telling you because you figure that I should know what I'm talking about, right? But in those like other classes that you have to take if you major in math, you're looking at the reasoning behind why that actually works. Like somebody at some point had to figure out that that for sure worked every time, and they reasoned through it in a manner similar to this. So like everything I teach you in math has like a proof behind it. Like mathematicians worked through it and made sure it worked in every single case, and a lot of them have names and properties and stuff that you apply. So if you major in math, be ready for some of that. We're not going to do it intensively here. If you major in math, you'll get a taste of it. But now, if you Caleb's, are you going to still major in math? Where are you going? You're going to see Charlotte. Do they do math education? Or is it, yeah. Math education, you might not have to do quite as much of it. if you do like a straight math degree. Because at Meredith you couldn't get, like, education was an add-on. You had to major in something, and education was an add-on to it. So I have a Bachelor of Science in math, like a straight math degree. I know, like, App has a secondary math degree where you do more of the teaching side, a little less of the math side. So you might not have to do as many of those classes, but you'll probably have at least a couple. Yeah, it's going to be fun. Math is so fun. It's so much fun. I will admit, a few of those proof classes, I appreciate them, but I did not necessarily think they were fun while I was doing it. All right, but that's enough about that. Just a inside view into what you might run into if you think math might be for you. Some of you are like, no, thank you. All right, secant of theta is 1 over cosine of theta. And if you think about that, that should make sense because it's just the reciprocal. Like, cosine is cosine is adjacent over hypotenuse. Secant is the reciprocal of that, hypotenuse over adjacent. So if we do 1 over that, it's just going to flip it. Cosecant of theta is 1 over sine theta. And then cotangent of theta is cosine theta over sine theta. And I could go through similar logic for all 3 of these, but we won't spend our time doing that. Okay, these right here, you need to have these memorized well, because I will not give them to you, so you need to have them memorized well. Tomorrow, I will not give them to you whenever you have your quiz, but you're going to practice them enough today that hopefully you should be good on those. To help me remember, tangent you just need to memorize. Cotangent is just flipped. They go together. It seems like sine and cosine should go together, but they don't. Tangent, cotangent go together. They're just reciprocals of each other. Okay? Secant and cosine go together. They are reciprocals of each other. That's 1 over cosine. Cosine is also 1 over secant, although we don't need to know that right now. And then cosecant and sine go together. So I remember that there has to be a co in every pair. Tangent and cotangent go together. Then secant is going to have to go with cosine. It cannot go with sine because if you have secant and sine together, they don't have a co. Right? So secant and cosine have to go together. And then cosecant has to go with sine. You couldn't have cosecant with cosine. You'd have 2 cos. And that would not work. You can't have 2 cos. You can only have 1 co in every pair. Yeah. 1 co per pair. No more. No less. So. All right. All right. Okay. So, all right, let's look at how to use the unit circle. And on these, I did all radian values on the ones we're going to practice right now. When you get to your homework, it's going to have degrees some, but in general, I find students are usually really good with degrees and need practice on the radians. So, like, instead of asking for sine of pi over 2, I could also ask for sine of 90 degrees, and that would be the same. All right? So these will be the same. But we're going to practice the radians because I usually find that's where students have a little more trouble dealing with those. And they're usually able to go back to degrees really easily. So, sine of pi over 2. If you have sine or cosine, and it's a unit circle value, it's really straightforward. So, sine is your y-coordinate, cosine is your x-coordinate. I'm going to go to pi over 2 right here on my unit circle, and tomorrow on your quiz you will have your unit circle. You can look at it. So you got pi over 2, and it's your y coordinate, which would be 1. So the answer for this is 1. So if we are doing cosine of 5 pi over 6, 5 pi over 6 is right here on the unit circle. Cosine is my x coordinate. The x coordinate right here is negative square root of 3 over 2. So cosine of 5 over 6 is negative square root of 3 over 2. So you're going to look at your angle, which is pi over 2, right here. And then sine is going to be your y coordinate. So you're going to look at the coordinates to go with it, and it's the y coordinate. So all right. Okay. If you want to work ahead, you may work ahead, but you must do so silently. Okay? If you want to work ahead, you may work ahead, but we're not discussing right now. Valeria, are y'all on the one we're on right now? Or are y'all working ahead? Okay. All right. So you're finding sine of pi over 2. That pi over 2 is an angle. Okay. So you're going to go on your unit circle to where you have the angle of pi over 2. Right. So right here we are. That is our spot that we're looking at. If you're looking for sine, it is your y coordinate. So the y coordinate of that point is 1. So 1 would be your answer. Okay, so, all right, 1 and 2 are really straightforward because they are on the unit circle. 3 is not. Negative pi over 3 is not anywhere on that unit circle. So you got 2 options on how to deal with things that are not on the unit circle. If you are a very visual person, the unit circle goes in the counterclockwise direction. If we go clockwise instead, it's going to be negative values. So we could look right here. And so like this distance right here, that is the distance of pi over 3. Right, so if we're thinking about this visually, when we have negative pi over 3, it's that same distance, but in the opposite direction there. So that means you would end up at 5 pi over 3. So those are what we call coterminal angles. They have different names, but they're at the same place on the unit circle. So sine of negative pi over 3 is the same as 5 pi over 3. So if we're looking at this spot right here at 5 pi over 3, Leah, what would our sine value be there? Okay, is it x coordinate or y coordinate? Sine, is that x coordinate or y? It is y coordinate. What's your y coordinate at that spot? Very good. Negative square root of 3 over 2. So every value that you get, even if that number is not on your unit circle, there is an angle that matches it that is on the unit circle. So negative pi over 3 is the same as 5 pi over 3. Now, sometimes these are hard to figure out what they are. Now, this one's not terrible to look at visually. You can see like you're going, instead of going this direction, that amount, you go this direction, that same amount. But sometimes it may be more than one rotation. It might be hard to see. So let's make ourselves a note up here. You can always add or subtract 2 pi to get a coterminal angle. And if we're doing degrees, it would not be 2 pi. What would it be if it were degrees? 2 pi? 360. All right, so what that means, like if you think about, like if I'm standing right here, and you tell me, well, let me start right here. This is like 0 degrees, right? If I'm standing here, if you tell me to turn 90 degrees, and I'm going in counterclockwise direction, I would turn this much, right? And I'd be facing this way. But if I'm standing right here, and you tell me to turn, what would it be? 420? 360? No. What would be a whole turn and a quarter? 450. Tell me to turn 450 degrees, right? I would turn, I had 450 is more than 360, so I'd have to turn all the way around. Right here's 360. Then I need to go 90 more. I'm still facing the same way, right? So 450 and 90 are going to look the same, right? It's the same thing when you're not dealing with degrees. When you're dealing with radians, 2 pi is a full rotation, right? So when we have values that are not on the unit circle, we can always add or subtract 2 pi. Now, you may want to do it visually instead, but like, for example, with negative pi over 3, it's not on the unit circle. So if it confused you, that counterclockwise, clockwise stuff, negative pi over 3 is not on the unit circle. It's too small. It's negative, right? So I need to make it bigger so it will be on the unit circle. So if I add 2 pi, right? Now, to add 2 pi, I've got to get common denominators. So I'd have to multiply the top of this by 3 and the bottom of this by 3. So I would really be doing negative pi over 3 plus 6 pi over 3. And that would give me 5 pi over 3. Right, which is where I was looking at on my unit circle. If you're good at doing this visually, you don't have to do that, but sometimes some are harder than others. Okay, so let's think about sine of 3 pi. Is 3 pi on the unit circle? No. So, is 3 pi too big or too small to be on the unit circle? Too big. So since it's too big, we could add or subtract 2 pi always, and it's going to give us the coterminal angle. So in this case, we want to subtract 2 pi. And so it's going to be the same as sine of just pi. Right? So, sine of pi, pi is on the unit circle. So, pi is the same as 180 right here. Luke, if I'm looking for sine of pi, what is that going to be? It is 0 because it's our y coordinate, right? So we get 0 for that. All right, here's one that's a little harder to do visually, although you can do it visually. I'll show you in a second. But negative 11 pi over 2. Is it on the unit circle? No. Is it too big or too small? Too small. So if it's too small, we want to add 2 pi till we get something that's on the unit circle. So negative 11 pi over 2. If I add 2 pi, to add it, I've got to have common denominators, which means I need to multiply the bottom by 2 and the top by 2. That's a negative 11 pi over 2 plus 4 pi over 2. And that is going to give me negative 7 pi over 2. Is that on the unit circle? No. You can, but, if you had told me whenever I was turning my 90 degrees, right, I could do 90 degrees, or I could do 450, or I could spin around another turn, right? I still in the same, I could just like spin a bunch of times, right? So you can add or subtract 2 pi as many times as you want. You're going to end up in the same spot, right? You could tell me that I needed to turn, like 12 pi. And that would be 6 rotations. And I just spin 6 times, but I'd end up in the same spot. So we're going to just keep adding. So negative 7 pi over 2. Is that all right with you guys if I go ahead and do 4 pi over 2? So I'll do common denominator, right? That is 2 pi, just with common denominators. So that'll give me negative 3 pi over 2. Is that on the unit circle? Not negative. There's a positive 3 pi over 2. So negative 3 pi over 2 plus 4 pi over 2. This finally gives me 1 pi over 2. Is that on the unit circle? Yes. So cosine of negative 11 pi over 2 is the same as cosine of positive pi over 2. I don't think so. I'll show you how you can look at it here in a second. I'll show you how we can look at it here in a second.
Divide like 10 by 2, that would
if you kind of think of this as like negative 5.5 pi, sort of, is that kind of what you're thinking?
I don't know, but I know it's working.
Okay. All right. We'll see. If you're getting them right all the time and it's working in your mind, that's fine. All right. So cosine of pi over 2. So whenever we look at this Mallory, if we're finding cosine of pi over 2, we'll go right here. Cosine is at my x or my y coordinate. X, so what would I get for this one? 0.
If you divide by the greatest common factor, like if you divide 10 by 5, then you just get like 1. There's only 1 more than 10, so you get 1 pi. You know?
Yeah, but how do you know whether it's positive or negative? And all right, this is what. Now I have dealt with the unit circle for a lot, so I've looked at the unit circle a lot of different ways and understand it in lots of different ways because I've taught it for so long. You guys have just had like a introduction in Math 3, and then we're going over it more now, but you're like still babies on understanding this stuff. So I don't usually do what I just did there. I know that pi over 2 is a quarter of the circle, right? So if it's negative pi over 2, this is what I do. A quarter of the circle is pi over 2. So if it's negative 11 pi over 2, this is negative 1 pi over 2, negative 2 pi over 2, negative 3 pi over 2, negative 4 pi over 2, negative 5 pi over 2, negative 6 pi over 2, negative 7 pi over 2, negative 8 pi over 2, negative 9 pi over 2, negative 10 pi over 2, negative 11 pi over 2. And I end up at that pi over 2 spot. You don't have to do it that way. You can just add or subtract 2 pi. Yeah, you can just if you have 14 pi over 2, you could just go around the circle, like a quarter of the circle, each quarter of the circle. And if it's positive, you're going in the counterclockwise direction. If it's negative, you're going in the clockwise direction.
Yeah, but then 14, you can divide that by 14. Whatever you want, so you get pi around that.
14 pi over 2 would be 7 pi. It'd be pi.
Oh, yeah, so it's not divided, it's not divisible by 4.
Yeah. Yeah. Yes. Yeah, always start from 0. If it is positive, you're going in the counterclockwise direction. If it is negative, like it was this time, you'll go in the clockwise direction. So you go the opposite direction if it's negative. Okay? If you're a very visual person, that may help you. If not, you could always do what I did here. It just takes a little longer. Okay? All right. Let's see. Sine of 3 pi over 4. That one's on the unit circle. Lucian, what is sine of 3 pi over 4? It is square root of 2 over 2. Very good. Uh-oh, tangent. Pi over 4 is on our unit circle, so that is easier. It's on the unit circle. But tangent is not on the unit circle. But I taught you that tangent is what, Avery? Sine over cosine. So what we're going to do is tangent of pi over 4 is going to be sine of pi over 4. Pi over 4 divided by cosine of pi over 4. So if we go to pi over 4, our y-coordinate is our sine, so that's square root of 2 over 2. And then our x-coordinate is also square root of 2 over 2. And what do we get there? 1. Okay? Secant is 1 over cosine of pi over 2. Pi over 2 is on the unit circle. That makes it a little easier. Okay? So, I go here. What is cosine of pi over 2? Oh. No. Is not. Because friends do not let friends divide by 0. It's undefined. It's undefined. 0 on the bottom is undefined. Okay? Cotangent of pi over 6, this is going to be cosine of pi over 6 over sine of pi over 6. Alright, so at pi over 6, cosine is my x-coordinate, so that's square root of 3 over 2, and then sine is 1/2. Now, I don't think they're probably going to let us leave it as a complex fraction like that. So, when we have complex fractions, that's fraction divided by fraction. Dividing fraction is easy as pie. Flip the second and multiply. These 2's right here will cancel each other out. You'll just get square root of 3. Alright, I'm going to do this last one. I'm going to let you guys do some of these others on your own. So 1 over sine of 2 pi over 3. Sine of 2 pi over 3 is our y-coordinate. It's going to be square root of 3 over 2. So I get 1 over square root of 3 over 2. So they're not going to let you leave it as a complex fraction, so that's 1 times 2 over root 3. So you're getting 2 over square root of 3, but you're also not going to see the answers to these left where they're not, where you have a square root in the bottom. So you're going to need to square root, multiply by square root of 3 in the top and bottom to rationalize that. So you're going to get 2 square root of 3 over 3. Okay. So much time. I tell you what. Let's go ahead and go to our worksheet. I don't think there's. Let me make sure. Is there anything here? I don't think there's anything there that I need to